Welcome to the first session on series of lectures in data structure. This is Syed Mujahid, working as an associate professor in Lord's Institute of Engineering and Technology in CSE AIML department. Today we are going to discuss stack as a data structure. We are already familiar with different concepts in data structure. So this is one of the important concept which we use in our daily life. So first of all, we should know what is a stack. So in data structure, stack is a linear data structure which follows special order. That is, all the operations are performed at one end only. That is top. Okay. So here insertion and deletion takes place at only one end, whereas in other data structure we can have different ways of performing operation. So that's why this stack is a special kind of data structure. So here I'm giving the brief outline of stack. So first of all, we'll see what is definition of stack. Then next we'll see what are the different operations which we can perform on a stack, and then applications of stack. After that, we'll see how to implement stack using arrays. Although there are different ways to implement stack, by using linked list also we can implement the stack, but here we are going to discuss by using arrays. Next we will discuss advantages and disadvantages of the stack. Okay, so here just I will introduce you what is definition of stack. So here you can say that stack is a data structure of ordered items, okay, such that items can be inserted and removed only at one end. So in our daily life we see stacks of CDs, stack of plates, stack of books. So these many stacks we are using in our daily life, and many more items we put on the stack. So here it follows specific order. So what is that order? Stack is a LIFO, that is last in first out. It follows the principle of LIFO or FILO. FILO means first in last out. The element which we insert first will be removed at last, or the element which we insert last will be removed first. Okay, now here why we are going to use stack? So what are the different applications of stack that we have to understand, so that it will be easier for us to learn that concept. If we don't know the application of a particular thing, then it becomes useless to learn that thing. So here different applications of stacks are there. So first application from computer point of view is that program execution. While we are executing a program and we are calling functions, so all the information related to that function will be stored on the stack, so that while returning from the function call we can resume the work from the place where we left off. Okay, next, for parsing purpose in compiler designing we can use stack. Then in the evaluation of postfix expressions we are going to use stack. Again, we have seen that we write programs for reversing a string. So in any language, any C, C++ or Java, in any of the language we write a program to reverse a given string or a word. So there are some letters in the word which we want to reverse. So for this purpose we can use stack. So see, for example here, see, for example, I have been given a word with letters A, B, C and D. Then if I am asked to reverse the letters of this word, so what I will do, first of all I will insert all these elements in the stack in this manner. First A will be inserted, then next B will be inserted, then C will be inserted, and then finally D will be inserted. Okay, so this is our topmost element on the stack. Now while we remove the elements from the stack, as we know that the topmost element is removed first. Okay, so that's why the first element which we will print, that will be D, and then after that C will be printed. Okay, then after that B will be printed, and finally A will be printed. So this way we can reverse a given string using stack. So there are so many numerous usage of stack. Again, we can use stack for undo or redo mechanism in the text editors. Okay, just we are using MS Word, Excel or Notepad or any other word processing applications. There what we do, sometimes we need to undo some operations. Suppose we have typed some letter and we would like to undo it, so we can use Ctrl Z. Okay, so we can use Ctrl Z. So this is the one of the application of stack where we can perform redo operation or undo operation depending upon the need. Then next, we are using internet in our everyday life. So here we are using browsers. So in browser we use stack to keep track of the history of websites, because whenever we are browsing some websites and we would like to go to the previous page which we have already visited, then you can just click back and then it will take you to the site which you have visited immediately last one. So these are the numerous applications of stack, and there are many more applications. So just to limit it, we have mentioned here few of the applications. Next, we have to understand how to implement the stack. Okay. There are various ways to implement stack, and some of them are just using an array or using a linked list. So these are two popular implementations of stack. We can implement the stack using an array or using a linked list. So here in array, the memory allocation will be static in nature, because we have to specify the size of an array in advance. Whereas if we don't want to fix the size and we are in need of inserting unlimited number of elements onto the stack, then we can go for the next type of data structure, that is linked list. So using linked list, we can insert as many elements as we want. But in arrays, the size is always fixed. Suppose here we want to declare an array, declare a stack. So we can use any name, variable name. Before that we have to write the data type of that variable name, and then we have to specify the size. So it means that the maximum size of the stack will be 10. So we cannot insert more than 10 elements onto the stack, and the index will always start from 0. Okay, so here if I'm going to represent this logically, I will draw the array like this. So this will be the 0th index and this will be 9th index, because the maximum size is 10 and the arrays will store up to the max minus 1. These many elements will be stored on the array. Now if we will turn this array into the form of stack, so then we have to rotate this in upward direction, and you can see we can represent the stack in this manner. So here the 0th index will be here, and then first index, second index, up to 9th index. Okay, now this way we can represent the stack in a logical fashion. Moving towards the next, we are going to understand what are the different operations which we can perform on stack. So here numerous operations are there, but to mention few of them, the first one is push and the second one is pop. So these are the fundamental operations which we perform on stack. Although there are some other operations also, just like peek, or we say sometimes seek, or sometimes we use the term top. So here push operation is used to insert an element into the stack, that is placing an atom on the stack. So that is the push operation. Next operation we have peek. Here peek means it will just show us the topmost element of the stack. It will not remove the element from the stack, just it will show the topmost element. Next, the operation of removing an element from the stack is pop. Here we are going to remove the element as well as we can see the element also. So this is the third operation, and many more operations can be performed there, just like traversing the array or searching an element from the stack. So these many operations are there which we can perform on the stack. So you can see here in this figure, we can see operations of stack are performed. Here all the elements are inserted from one end, that is the from the top, and also removal of the element is from top only. So that's why this is the unique data structure which we use at special places where we need to insert the element from one end and remove the element from the same end. Okay, so you can see here all the data elements are inserted from the top also, and all the elements are removed from top only. So here now how to implement the stack. So whenever we are going to implement a stack, first we will use the variable top, which will always point to -1. Why -1? Because we know that array index starts from 0, but 0 means here the first element will be stored at the 0th index. So to show that the stack is empty, we use the index value as -1 to indicate that stack is empty. So here top will be initialized with -1. Okay, and then next, whenever we are going to insert an element, just like here we have shown that we are going to insert element 10 with the help of push operation. And here one more thing we can notice that we are using an argument 10 while pushing an element onto the stack, but while removing an element from the stack we don't pass any argument, simply we write bracket. Just like here you can see push, and the value which we are passing is 10, so 10 will be stored at the index 0, but before that we will increment the value of top. Okay, how? By writing top plus plus. Okay, so whenever write top plus plus, the value of top will be incremented to 0. Initially it was -1, so now it will become 0, and the element which we will insert will be stored at index 0. Next, if we are going to perform one more operation of push with the value 20, then it will be stored at index 1. So here 10 is stored at index 0 and 20 is stored at index 1. So similarly we can go on inserting the elements up to the maximum size -1. Why -1? Because suppose here we have shown 6 slots, so it means the maximum size is 6. Okay, but as we know that in arrays we are going to store the elements from 0th index, so the size will be from 0 till 5, so that will be total 6. So that's why when we want to show that our stack is full, we can say that if top is equal to max -1, it means our stack is full. Okay, so here we have shown just 2 elements, and similarly if we are going to perform the pop operation, we are not going to pass any argument here. You can see here pop and empty parenthesis. So here what will happen, the topmost element will be removed from the stack. It's not like we can remove the element which we want. Okay, here the topmost element which is on the top of the stack, that will be removed on any cost. Next, here we will see the algorithm for implementation of stack. So here before insertion we have to understand whether our stack is full or no. Why? Because if our stack is full, we cannot insert more elements, so it will throw an error message that overflow. Whenever we will try to insert an element onto the top of stack, and if the stack is full, the system will throw an error message, stack overflow. Why? Because we have crossed the limit. Okay, so here before inserting an element, we'll check whether the top is equal to max minus 1. What does it mean? It means that stack is full. If the stack is full, then simply we will display the message overflow and then return from the program. That is, we will go to the step number 4, that is end. Otherwise, what we will do, we will increment the top pointer, that is because initially top was -1, so it will be incremented by 1, that is top plus plus, and it will point to 0th index. So here top will be set to top is equal to top plus 1, and then the element which we want to insert will be stored at stack of top. Okay, stack of top is stack of 0th index. So this element will be stored. So this will be the push operation. Similarly, we can perform pop operation. So here, before performing the pop operation, what we have to check? We have to check whether the stack is empty or no. Why? Because if the stack is empty, we cannot remove any element from the stack. So for that purpose, we have to check whether top is equal to null. If top is equal to null, it means there is no more element in the stack. So simply what we will do, we will print a message stack underflow and then exit from the program, that is go to step number 4, that is end. Otherwise, if the stack is not empty, then we will take that value out of the stack and put in the variable val. Okay, so in this variable val, the topmost value will be stored, that is stack of top. And then after removing the element from the stack, we have to decrement the top pointer. Okay, so then what we will write? Top is equal to top minus 1. Otherwise, we can write top minus minus. So this is the simple pop operation which we perform on the stack. Moving on to the next slide, we can see the peek operation, which is also known as seek operation, or the top element which we want to see, that operation peek or seek is used. So here the element is not removed from the stack, but just topmost element is displayed to the user. Okay, so now here you can see if top is equal to null, then we will print the message stack is empty and then come out of the program. Otherwise, what we will do, go to the step number 3, and then here what we will do, return stack of top, because we know that always the element which is removed, that is topmost element. So here we are going to return the topmost element from the stack and finally come out of the program. So then this is the C program implementation of the stack operations. So you can see here, I have not written here complete program, but just segment of the program, just to understand how the push function works and pop function works. And similarly, we can use the peek function to find out the topmost element of the stack. So now you can see here, using push function, whose return type is void. Since I'm writing a function and the value will be taken inside the function, I have not passed any argument to the push function. If you are implementing it in another way, then you can pass the value directly to the push function. Now here in this program segment, we have declared one variable val of type int, and then here before inserting an element, what we are going to check, if top is equal to n minus 1. So what is n here? N is the maximum size of the stack. So if top is equal to n minus 1, then we are printing the message stack overflow. Else means the stack is not full, so the control will be passed to the else part of the program. And here what we are going to write, we are asking the user to enter the value. Okay. With the help of scanf function, we are going to read the value from the keyboard, and then we are going to increment the top pointer's value, that is top is equal to top plus 1, or you can write top plus plus also. And then that value we want to insert onto the top of the stack, so we are writing stack of top is equal to val. So this is the simplest program segment for pushing or inserting an element on top of the stack. The next operation which you want to perform is pop means removing an element from the stack. So here, before, as we have seen that before removing an element, we have to check whether the stack is empty or no. So for this purpose, what we are going to do, we are going to check if top is equal to -1. So what does it mean? It means the stack is empty. There are no more elements in the stack. So here simply we will print stack underflow, and if some elements are there, then what we are going to do, simply decrementing the value of top. So top is equal to top -1. Then you may have one doubt that here simply we are going to decrement the value of top, then where is our element which we wanted to remove? So that value you can take in another variable and display it to the user. Otherwise simply it will be treated as a garbage value, nothing else. Okay, so now moving to the next operation, that is peek operation. Here, as we have already discussed, that peek operation will display the topmost element of the stack without removing it from the stack. So it will not remove the element from the stack, but just it will display the topmost element. So here what we are going to see, if top is equal to -1, it means stack is empty. Then we are going to display the message stack underflow. Else, in the else part, we are going to show the topmost element, that is percentage and stack of top. Now the next operation which we can perform on stack is traversing the stack. It means displaying all the elements of the stack. So here for this purpose we have shown with the help of a show function, and also the return type is void, because here the displaying of elements is taking place inside the function only. So here you can see we are using a for loop, so which we are going to initialize with the variable I is equal to top. So top means the topmost element index will be stored at the variable I, and if I is greater than or equal to 0, then I minus. So we are going from top to bottom, and here we are going to display all the elements with the help of stack of I. And then after that, if we are going to check if top is equal to -1, it means stack is empty and no more element to display. So this is the simple operation to traverse stack or display all the elements of stack. Now we have to understand what are the advantages and disadvantages of the stack, why we are going to use the stack, what are its various advantages. So let's try to understand. Here, first thing is that stack helps to manage the data in the last in first out method. Okay, because whenever we are in need of displaying the data in this fashion, then we have no other option other than stack. Just like we have seen various applications of stack, so this is also one of the advantage. The next advantage you can see, although there are numerous advantages, but here we have mentioned few. So here, when the variable is not used outside the function in any program, then we can use stack. Next advantage you can see, it allows us to control and handle memory allocation and deallocation. Because whenever we want to allocate a memory, and after the completion of the program execution, we can deallocate the memory. So that task can be performed with the help of stack. And then it also helps us to automatically clean up the objects. Okay, so it means garbage collection. In object-oriented programming also we use this concept of garbage collection, so that garbage collection can be performed with the help of stack. So these are various advantages of stack. Now moving on next to the disadvantage of stack. So we can see some disadvantages are there which are associated with the stack. So what is the first disadvantage? Here, insertion and deletion can be performed at only one end. So this is the major disadvantage of stack. Now next disadvantage is that the element being inserted has to wait for longest time to get popped off. Okay. Why? Because see, suppose this is our stack, and here if suppose I have inserted some elements here, suppose 10 has been inserted first, the next 12 has been inserted, 20 has been inserted. Now if I want to remove this last element, that is 10, then what I have to do, I will have to wait until all these elements which are top of the 10 are removed, then only I can remove the last element, that is 10. So this is the disadvantage, that all the elements which are on top of the particular element has to be removed first, then our desired element can be removed, that is means that can be popped off. Now next disadvantage is that here only one element on top position can be deleted at a time. No more elements, means we cannot delete elements randomly, or we cannot delete more than one element at a time. So this is also one of the disadvantage. And moving on to the next disadvantage, it has very limited memory. In the memory of computer, you can see stack has been allocated limited amount of memory. And next disadvantage here is that random access is not possible at all. What does it mean? Suppose here I have inserted these many elements, suppose 4 elements are there, and I want to delete the element which is at index 1, and there are 4 elements, so I cannot delete the element which is at index 1 randomly. Why? I will have to wait till all these elements are removed from the stack first, then only I can have access to this element which is at index first, and then I can delete that element. So this is the one of the disadvantage of using stack. Okay, so here we are going to stop, and maybe in the next session we are going to see what are the different data structures, and what is queue particularly, and how to implement the queue. Thank you so much for watching.